from the properties of Laplace transform, another two properties are initial value theorem and final value theorem. Now we have to discuss initial value theorem standard statement and final value theorem standard statement, and later the derivation of initial value and final value theorem, right? So first of all, we'll go through the initial value theorem. Initial value theorem. So this theorem is used to find the initial conditions of the time domain function. Sir, whenever one time domain function is defined, to find the initial conditions of the time domain function, this theorem is used, right? So that's why here always we have to take a t tends to 0. Initial condition means exactly its starting position. To find the differentiation purpose, always we have to assume t tends to 0. So exactly at t is equal to 0, what is the behavior of the time domain function and what is the behavior of the frequency domain function. So for that purpose, just I am writing one standard equation here. Laplace transform of x of t. Laplace transform of x of t is x of s. So time domain is converted into frequency domain. Then in this time domain, if time is 0, that part I am writing like this. Limit t tends to 0, x of t is, this is here, limit t tends to 0, x of t, this is equivalent to x of 0. So in time domain function, t replaces with 0, then in frequency domain, s becomes here infinity, so that's why we have to write like this. Limit s tends to infinity, s into x of s. This is the statement of initial value theorem, right? In time domain, if time becomes 0, in frequency domain, frequency becomes infinite, because time and frequency, these two are inversely proportional, right? The statement explains limit t tends to 0, x of t is equal to limit s tends to infinite, s into x of s. Now we have to prove this. So to prove this theorem, differentiation property is used. So first of all, I am taking here differentiation property. Laplace transform of d by dt of x of t. Laplace transform of d by dt of x of t explains the integration is from 0 to infinity. Just I want to write the Laplace transform basic equation here. This given function is d by dt into x of t, right, as it is, into e to the power of minus st dt, right? So here I have applied the Laplace transform of d by dt into d by dt of x of t. So differentiation of the time domain function. So Laplace transform of d by dt of x of t becomes here integration from 0 to infinity. Write this function as it is into e to the power of minus st dt. Then from the properties, from the differentiation properties, our differentiation property, one standard equation is there. Laplace transform of d by dt of x of t is s into x of s minus x of 0 is equal to, this side equation I am writing as is 0 to infinity d by dt into x of t into e to the power of minus st dt, right? LHS equation, RHS equation. Now I want to apply both sides, limit s tends to infinity, this relation. Apply both sides, limit s tends to infinity. So now apply limit s tends to infinity on both sides, right? So just I want to apply s tends to infinity on both sides. Then what happens here? So limit s tends to infinity, s into x of s minus x of 0, right? And this side I want to substitute limit s tends to infinity here. If you substitute here in s tends to infinity, e to the power of minus infinity becomes 0. So the complete equation becomes here 0, because e to the power of minus infinity is here 0. This becomes 0 now, right? So this is 0 and here x of 0 is there, so there is no s terms. Then I want to take this x of 0 right side, then it becomes positive. So x of 0 is equal to, so the left side equation explains limit s tends to infinity, s into x of s. See, limit s tends to infinity, s into x of s is equal to x of 0. X of 0, that explains the limit t tends to 0, x of t. So this is the standard statement of initial value theorem. So initial value theorem explains in time domain t is equal to 0, in frequency domain s becomes infinity. So limit t tends to 0, x of t is equal to limit s tends to infinity, s into x of s. So statement and derivation part. And similarly, I want to take another theorem. The theorem is final value theorem. Final value theorem. See, final value, that name explains. Now we have to take the t value is infinite. Final condition, steady state condition. Right? So final value means there we have to substitute t tends to infinity. If the time becomes infinity, frequency value becomes 0. Right? Both are inversely proportional. That's why the statement explains here, limit t tends to infinity, x of t is equal to limit s tends to 0, s into x of s. This is x of infinity here, x of infinite. That means this t becomes here infinite. In frequency domain, s becomes 0. So this is the standard statement of final value theorem. So to prove this theorem, again I am taking this equation. So this equation directly I am writing here. So this equation explains s into x of s minus x of 0 is equal to this integration. Right side equation is integration is from 0 to infinity d by dt of x of t into e to the power of minus st dt. So here I have applied limit s tends to infinity on both sides. Now here I want to apply limit s tends to 0 on both sides. Right? So now I want to apply limit s tends to 0 on both sides. Then the left side equation becomes here limit s tends to 0, s into x of s minus, here s term is not there, that's why directly I am writing x of 0 is equal to, and substitute s tends to 0 here, e to the power of 0, value becomes 1. So e to the power of 0 is 1, so now this value becomes 1 here, and the remaining parameter is integration from 0 to infinity d by dt of x of t. So integration operation, differentiation operation, both are cancels, but their limits are there. Those limits I am substituting now. The limits are from 0 to infinity. Right? So integration of d by dt of x of t is x of t. Integration of d by dt of x of t is x of t. Right? And limits are here 0 to infinity. Substitute higher limit and lower limit. Higher limit is infinite minus lower limit is 0. So here x of 0 is there, here x of 0, these two cancels. X of 0, these two cancels. Then finally which becomes here? X of infinity. This is x of infinity. X of infinity is nothing but limit t tends to infinity, x of t is, LHS equation is here, limit s tends to 0, s into x of s. So this explains the standard statement or standard equation of final value theorem. So final value theorem and another is initial value theorem. These two are important because these two are used to find the initial and final conditions of the system or initial and final conditions of the signal. Right? So what is the initial behavior of the system? That is explained by initial value theorem, and the final behavior, that means steady state condition. Steady state condition of the system is explained by final value theorem. So these two are used to find the initial and final conditions of the system. So please take this now.